I'm alive. It's alive. Anyway, yeah, that's you don't be that sure about it. You know, I'm going to be describing Perl test. Does anyone here test things with Perl already? People, okay, so you've typed make test and you've seen that sort of thing. Perl is kind of interesting because if you look at all the languages, a lot of people spend enormous amounts of money, time, effort describing how their language is better in about one thing or another. It's theoretically nicer or it's more complete. If you look at Perl, one of the things that just pervades everything you see in the language is testing. Perl comes with, I forgot how many thousand tests now. Everything you write has tests. And there's sort of a culture of testing that's built up around Perl over time that really makes it easier to test things, and the language helps a lot. The test modules in Perl, I'll talk about a lot of those, make it so that you can test things, you can write tests of your tests, you can design new ways of testing things pretty easily. There really isn't much you can't test easily with Perl. It's a great glue language for that. Anyone here have modules on CPAN? You get the little nastygrams from the CPAN reporter, the smoke tests. One of the things that we have that I don't know anyone else does is everything on CPAN is subject to being yanked out, shoved up, JRandom machine with any version of Perl, whatever operating system, and done a make test on it. And you get those every day. So I don't have a Windows machine, but I know which modules I have don't work on Windows. CPAN reporter, does anyone use those? The reporter, have you seen that? Things work, where they fail, they can see if things blow up. And again, I don't know of anyone else that really does that. And the language helps too, the ability to use introspection. I'll be showing you a bunch of tricks you can use with that make the testing easier, checking test coverage, being able to mock parts of the language in order to force portions of your code to run. All put together, it's a great testing environment even for languages that aren't Perl. This is a great book. Has anyone read this? Perl Testing Notebook? Got a couple of hands. Just go buy it. Walk out of here after Tim Bunn. Stay for him. After that, just walk out, go buy it. It is probably one of the best how-to books I've ever seen because every example starts out with so simple you can understand it. And then they extend it, but what if you wanted to do this, if you wanted to do that? So instead of giving you the massive example that no one understands and picking it apart, they start from the very simple and progress, and they actually show you how to do things you would actually want to do in stages. Great book. A bunch of the things in here I've taken from that. Test modules do most of your work. Test simple, test more. But there are also a lot of wheels. Don't reinvent the wheels. Use CPAN. Test deep allows you to test structures, builder coverage, object exercise. I'll be describing all those. Perl, with the symbol module, with its ability to evaluate code on the fly and actually modify the language itself while it's running, makes it easy for all kinds of things to happen. So, again, you can test language line, or you can test almost any language written using Perl. So you can glue your tests together. If you've got a combination of different languages and libraries that you have to use together, you can actually unit test them with Perl. So, devel coverage. I'll do a quick thing. Does anyone use that? A couple of hands. Okay, devel coverage tells you what ran. So when you're running a test, you can check whether or not you've actually taken all of the weird if logic. Another good thing about those is if you run a bunch of tests and you can't figure out how to make a test that reaches a certain branch, maybe you don't need that branch. If you can't understand how to reach it, and I've been in situations with code, people say, but we never tested this one piece of it. Well, because it can't, it can never run. Test Builder allows you to roll your own, completely own test environments. So a lot of these things are out there to make your life easier. You can also do things, a lot of people think, oh, testing, I do a unit test and I install a module. What if you're installing a database? You want to put the baseline data in, the standard fixed records. You can use a test that checks whether or not all of the records successfully were inserted. Would it be nice to do a check, know that everything was installed, and if you were missing one of your baseline records, at least get a report of it when you started? Daily cleanups in cron, things like that. There are a lot of things you can do with what are nominally test software. Am I too loud for people, by the way? Because I'm hearing echoes in here. No? Okay. If I rattle your eyeballs out, just put them back in and warn me. So the simplest thing is test simple. Anyone use that? I've got a couple of hands. Test simple is actually, you have a hardwired count. So you have test simple, you have test equals 6 in this case. And if you run a different number of tests, that will give you an error, which is good, because it means if you design the if logic, if you did whatever so that you didn't complete your tests, or you run extra ones is the usual thing. Oh, wait a minute, why did that run? You know, you'll find out about it. The OK is the basic piece of it, aside from the test count. You'll get output like this, what I've shown here. You have a count. If 1 is equal to 1, you'll get an OK. You compare 2 to 1, you'll get a not OK. That's what you know. But if you compare 1 and you don't compare 2, you'll get a message like the second one here. It looks like you planned 2 tests and ran 1. You know what you did. And frankly, that's what there is. Now, one of the things you can do with OK, you can give intelligent messages. Has anyone seen messages like these before? The last one is my favorite. File or directory not found. And you know exactly how to fix that, don't you? Or the other great one is they give you the base name without the directory path. You know, config.java not found. And it's like, wait a minute, there it is. I see it. If you spent weeks going through someone's test code trying to find where the thing was supposed to be, because it wasn't, and then you find out their test was bad. So you can do better than this. Rule number 1, when you're designing tests, test what actually matters. Don't just test frivolous stuff, but also report something useful with your test. So for example, if you, instead of file or directory not found, you can do something like this. Really easy to do. Does it exist? The underscores, by the way, save you from recalling stat every time. So this will say, find me a path. Here's a path. Is it existing? Is it a directory? Is it readable? Is it writable? Well, now if it blows up, someone can say, oh, gee, the mods of that directory are gone. The directory is missing. I mean, obviously, if it's not existing, you're going to get a bunch of failures. But you'll see the first one. You'll know that it's there or it's not. And by using the full path, somebody knows what they're looking for. They're not going to spend the next 3 hours hunting through the file system for what you might have been looking for. Or worse yet, they'll be hunting through your code and they'll modify your test so that it matches what they have and you'll never know why it works. Another thing people notice a lot of times is the number of quotes and parens, delimiters I use in my code. And I could write something like this. Can anyone tell me why these fail? It's pretty obvious. Nobody? What about now? Quotes are your friends. If you've got text you've read from a config file you've picked up from the environment, delimit it. Because extra white space is really hard to read on the screen when it's scrolling by you. So here, obviously, whatever was written may have read an extra space. It read a new line out of a config file. I didn't chomp something. The quotes make life so much easier. Just put them in. Another thing, a lot of times, and this is just OK, put what you expected and what you got. Whatever order you like them. I usually put whatever I expected in quotes and then what I got, followed by what I was expecting. If it's OK, you're going to get the same thing. Who cares? But when it fails, it really matters. If you look at these, the first 2 of them, probably the test failed. I was looking for something reasonable and didn't get it. In the second 2, I had a botched test. If I didn't print both of these, half of the time I'd have no idea why it failed. I'd have no idea what to look for next in fixing it. So case, put what you expected, put what you found. Sometimes, test simple usually is enough. I mean, if you test fail or they don't. Usually you can figure out how many tests you've got. There's a little extra bookkeeping to update a number at the front. And that may be enough. And that works for a lot of tests. And we're done. No. But wait, there is more. Test more. People use that a lot? Anyone? I got a couple of hands here. OK. These are a few of the things you get out of it. I'll be discussing most of these. And by the way, if people care, all of this is on SlideShare. So you don't have to write down the examples or anything. You can always come back and get it. You can sleep through this whole thing and just read it later if you want to. The good thing about test more is it gives you a lot of more specific ways to test things. One of the downsides to just using OK is you've got to come up with a Boolean for everything. And you either have a lot of variables that are the outcome of complicated tests, or you end up with tests that wrap around the screen 5 times because you're comparing something to a complicated regular expression. So by using test more, a lot of times you can make more succinct tests. So the first thing that I like, the flexible count. How many people here have updated a test and with test simple and had it tell you you had the wrong count of tests? Yeah, say goodbye to that. The plan is how you set the count. One of the neat things about test more is that you can plan the tests after you use the module. The good thing about that is if you've got a configuration file, if you're validating query output, you can set up the test and then put the count in. So you can vary the count based on what you know you're about to test. If you don't run the same number of tests for every input, don't plan it. There's a way around that. You don't always need a project that runs different numbers of tests. You can skip this and still get a reasonable test output. Because when you're done testing, you just say so. You say done_testing. At that point, your count is validated if it was present, and you get a report of what failed and what didn't. So if you're going to have if logic, classic cases, you hit the database, you do a query, and depending on what the rows return, you might run one set of tests or a different set of tests. If there's a different number, you're never going to get the right count. Don't sweat it. Just use done testing. Another thing, a lot of times, if you're finding that you keep hacking the number of tests, maybe you've got more than one test file. Remember, you can break these into multiple small tests. If you've got lots and lots of if logic in your test examples, think about breaking them down into separate tests that can do all or nothing. And then you'll get either no tests or a count that you know what it is. So if you have to finagle the count every 5 minutes, it's a good sign that your test files are too large. Notes. Does anyone here use notes? OK, we got a couple of hands. These are great. This goes back into the show what you expect, show what you found mentality. A note only shows up if you use prove minus verbose, or minus v. 99 times out of 100, you do not care what's in these. When tests pass, do you really, really, really care what every one of them did? No. So when they fail, all of a sudden you care. You're going to do it verbose, you're going to rerun the thing, you're going to save the output. That's when you want lots of nice, juicy details, like what directory were you looking in? What file did you get the configuration for the test out of? What database do you think you were connecting to? That's what these notes are for. So I can have something like this one where there's a path is reading the config, and it exists. Well, by putting this note up here, I can tell you where I got the value from. Would that save a little bit of time when you're trying to find out why I'm looking for a non-existent directory? Yeah. Anyone here ever connect to the wrong database to make a test? Yeah. So I got a couple. Yeah, that's my favorite. Put a note in there. Connecting to database X. Dump the DSN. Another thing is diagnostics. They're more useful for errors. They will show up with verbose or not. So the usual thing is you can do an OK. OK returns true when the test is good. Not OK, it gives you it gives you false. So you can run a diagnostic and say, fine, here's, database handle exists. We're connected. Or show me why I failed. Give me some details about it. Use the DSN. A lot of times people don't like to put the username and password in tests because you might leave it lying around on the disk. But you can put all that in here. Explain is neat also. It will dump a nested structure for you. If you use them at the beginning, they're great with note because you can dump an entire config file or config structure that you read out of a file. And if there are things that relate to each other, if you're not running some of the tests, if you're bouncing off of things, having that at the top, just run proof, tee it off to a file, you can see what it was you were using to try and make the connections. Diag, it's good because I can say, this failed, here's exactly what I was passing to the failed thing. So now here, if I get a database handle, or I can give you a diagnostic with the entire structure of what I was using, all the one-time setups, the DSN, the user, the password. Now you know what failed. You can go right to it and say, oh, I see that. The good thing about also using note and diag is now the messages on your OK don't need to wrap 5 times around the screen. Because most of the time, you're not going to list all of it. You're only going to tell people what blew up with the diag. So most of the time, it's these nice short messages that say, fine, this worked. Other versions of OK. There are times when, especially with regular expressions, string comparisons, using OK gets bulky because you're comparing long strings to long strings, things like that. So there are a bunch of these that are like. So you can say like stuff with a regex milk. And that'll tell you that it's not OK, it's very new cheese instead. So if you like Neil Simon. Anyway, but you'll see something, and this is where that diag comes in handy. Now you don't have to have this long message out here. I can say, look, I got what I expected. If it's milk, it's milk. If it's not, I'll tell you exactly what you got. There's also, you have a variable number of tests. Again, that's a lot of times I'll do this with databases, depending not on how many rows I got back, but what they contain. Some rows are just, there's more to examine. Or if you're validating object construction, you might do more if logic on one thing than another. That's where pass and fail work. Unlike OK, there's no test. It just puts a pass or a fail into the plan. So I can do something like this. I create an object. If I can create it, eval it. Evaluate what I got back, validate the contents, do whatever. There might be 50 tests in there. If I didn't get an object back, there's really only one thing to say. It failed. So instead of having to have OK 0 or something, fail just puts it in there. And it's a little bit easier to read than someone coming back and looking later and say, OK 0, what was that doing? You can also test for expected errors. Does anyone here ever pass junk to their constructors just to make sure that you reject the junk successfully? Yeah, so here's a great way to do that. Get new junk. If I didn't get an exception, the test failed. So this is a simple model for testing expected exceptions. Fail, by the way, returns false. Pass returns true. So that's why the 1 is stuck in there. But now I can say, look, either it successfully raised the exception and I'm going to examine what I got back, or I failed. And that's what I'll get in the test. Now, another thing, a lot of times you'll find there are times when you can't finish the test. You don't want to run them. You want to skip a fraction of them. You've seen a lot of these if you build DBI. They're internal tests that aren't worth running every bloody time because they're only for the developers. They don't apply to you. So you can save a lot of extraneous code if you use first bailout. Anyone use this? Seen it? Have you seen it before, people? No, we have one hand. OK. Bailout aborts all testing. It just takes it just takes prove and stops it. This is useful if you know that every test is going to fail. If you're about to test a database and you're going to pick up the database user ID and password from the environment and you don't have the password, it's not worth testing. Just bail out with environment missing something. So these are useful early. Don't run tests as super. One of my favorite things in Perl, though, is a great one. Guy had a CPAN module. And you would do the make test. And on the screen, it would print out rm minus rf slash space space or star or something. And then he would do a file find on the disk drive and block all signals. And after this went on for 5 minutes where you're frantically control-C'ing it and trying to kill the thing, a little message pops up. Why would you ever run something as super user if you didn't know what it was going to do? There are a lot of tests that don't, if you're going to unlink something, you probably don't want to be doing it as super user. I used to work on Unix phone support. And one guy, he couldn't get his machine working. He was really mad at us. All he'd done is remove this one directory of empty junk that had been there since the system was installed. And he had no idea what was wrong. And the guy was trying to clean up, he had too many inodes on the file system. And he had rm-rf/dev. And of course, one of the early things it blew off was dev console. So he had nowhere for the messages to go. Okay, it is too easy to make a mistake in a test. Putting a sanity check for super users. You don't need to be super user to maintain Perl. That's a separate talk. But a lot of times it's worth checking. If you're going to manipulate the file system, this isn't a bad thing to put in. Missing the data, you know, if there's no environmental DB, tell someone, I'm missing this. But then you can bail out with it. It's a really obvious message. They're going to see it because all the test stops right there. Again, if you're using test directories, if the directory doesn't exist, if it's not writable, just quit right now with a real message. Skip blocks. You've seen these a lot of times if you're testing LWP, DBH. If you don't have a network connection, don't do this. If you don't have expensive tests set in the environment, don't run them. These save people from running tests that don't matter. The good thing about these, you have a skip. People here use labels in Perl at all? Okay, so people have seen that. The skip label begins a block here. And in this block, you have the tests that might be skipped, along with some logic at the top that says skip, a reason, and a count. This allows you to have a plan and not fry the plan by skipping the tests. And then you've got some if logic. So if there's no environment for the test database, I'm going to skip these. Or it might be, you know, or no network available, you know, if not the network setting, if not whatever. But someone gets a report, skipped 14 tests and a reason. So this message is pretty important because you want to tell someone why. You know, expensive tests not set. So they don't have to sit there and reread your test file to figure out why the thing should have run. Really expensive tests. You know, the ones that are, there's stuff I test in some of my own code that if I do approve -R, it will take 3.5 days to finish. I might not want to do that every time I do a check-in. So, it just, you know, it slows the cycle down when you have to go to sleep a few times before, I mean, literally. So here, if expensive tests is not set, I'm going to have 12 fewer tests. And I've told someone, expensive tests, if you really, if you care, that's what'll happen. Another type, again, if there are half a dozen of these tests that are going to scan the file system, there's some systems that have tripwires on them, or if you're doing networks, if you're testing the network, do you really want to freak out the network admins by doing an nmap on a major server? Probably not. But if you're going to do that as part of your testing, you can tell people, you know, complete network tests is one in the environment, and I'll do all of these. Peachy. They were warned. They got what they needed. If it isn't, you won't. Again, if tests are super user, if you might be manipulating the file system, probably don't run them as super user. People can run those as a real person. In the end, you'll test simple is nice. It probably does a lot of things, but you'll almost always use test more. The flexible plan is a lot easier. The done testing without having to do a plan is worth it, especially when you're doing development. If you're doing a lot of iterative testing, having to go back and hack the count of the plan and count the number of tests you've added or subtracted is a pain in the ass. So you'll probably use this most of the time. Now, there's test deep. Anyone use that? We got to see if anyone knows. Okay, most people have seen it, but the quick on this one is a lot of times you get back a really bulky nested structure. These are great for testing database, by the way, because you can do a select all array ref on fixed data and test in one step, did I get what I expected? But if you have an array of hashes of hashes of arrays of arrays of hashes of objects, this will walk down it and it will tell you these are different here. So it does a nice comparison. It's also really great if you're checking initialization of objects, because you can have a large, bulky object structure, and it will check the object without you having to hardwire all the keys and call 45 methods to see what's inside of it. Devel cover will tell you what you executed. Now, one part of this is testing. You also use it, it's very good for benchmarking, because you might want to say, well, gee, if I just ran a large benchmark, did I exercise all the parts of the code? If they're really if you're trying to test only part of the code, did you pollute your benchmark by running parts of it that you didn't want to? Did I benchmark all of my error handling because I gave it bad data? I've seen that happen. Oh my God, this thing only took 5 minutes to run. We've done it. We've really oh no, it puked halfway through. Using devel cover with your benchmarks isn't a bad, if you do it once, isn't a bad idea. So to run this, what you do is you do cover minus test, or you can do a Perl minus m devel cover. And Ricardo showed us yesterday how to write your own devel modules and things. So what this one does is it just bookkeeps every line of code that gets run. Not how long it takes, just did I get there? And you get a test that will show you what actually ran. You run cover afterwards to generate the report. It's like an NYT prof. And that also works. Let's say you want a database to fail. And this is shamelessly stolen from the Chromatics book on the Perl testing how-to. If you want a database operation to fail because you want to test, do I correctly handle failures? And you can't assume SQLite is installed. You don't know what database someone has locally. Flat file databases are always a mess because you got to install them and clean them up, and you have all the error checking for did I clean them up properly. How do you guarantee something is going to fail? You can always write something that should fail, a database operation on a non-existent table or something. But how do you know that you didn't have a leftover copy of the table, that some jerk didn't have a table called foo just for the fun of it on their own? So the thing you want to do a lot of times is you're going to override a method, or override the class, or override core Perl to force something to fail or to track what happens so that you know the test exists. And you can get mock objects. You can fake a method in a class. You can even fake the functions in Perl so that you get known results. So let's say you're trying to connect with DBI. There's no way to guarantee if you give it a full set of arguments, there isn't a way to guarantee something will fail a lot of times because you can't tell. Maybe they do have a Joe Blow user. What I can do is this. I can go take the DBI connect and override it with a sub die. Bang! I'm going to fail. I know exactly how I'm going to fail, and I know exactly what error message I'm going to get. So if I've got a wrapper for the database handles, and it fails to connect, I can ask, does it correctly propagate the error message? Does it grab the right part of the error message? And do I get the error message I expected when it fails that way? By changing what it dies with, I can say, do I propagate if there's logic in your code that handles different connection failures differently, that has to give people clearer, more correct messages, maybe you go through and you can have this die with every single message you can get back that you're supposed to handle. And you know it's going to work. You don't have to guess. You don't have to play with fake databases. You don't even have to have a database at all, because you're actually changing the way the DBI handler works. You can force an exception. This is a thing I use a lot of times. If I want to fail with a message, anyone here use symbol? Ooh, this is a great just for day-to-day work, it's great, but for testing, it's wonderful. Chip Salzenberg wrote this. It allows you, with qualified a ref, you can generate a ref using the name. And it saves you from all the no strict and the evals and the weird stuff to get all the double colons pasted together. So what I've got here is a reference. I take a message, and I can qualify to ref it, which says given a name and a class. give me a reference to that symbol in the table. By undefining it, I save myself a nastygram about redefining a subroutine. By assigning it a sub, I can make that thing die with a message. This is a generic installer for dying the way you want to. You can take anybody's method in any package and make it die with your message. I mean, aside from playing with people's heads, this is a great way to test that you can handle all the exceptions properly. Because you can put most of the stuff in an array, force and just iterate, if this dies this way, does it die the way I expect? The downside of this is once I've done this, I don't set it back. So this is good for a one-shot test. I can change connect to a message, but once I've done that, connect is never going to work again. I can do multiple test failures by doing a force exception. Now I can eval whatever I want to and run multiple tests on it. Is this making sense to people? I'm getting some nods and some cross-eyed. The trick with qualified a ref is I'm grabbing the symbol table entry for a name in a package. If I assign a subroutine reference to that thing, I'm installing a subroutine.
So since you can't set it back, you end up with just a lot of really small test case files.
Bing, yes. Or what I do is you might do this. Let's just say there are 45 ways something can fail, and you know that it failed because of the test message. Stick every message that you might expect into an array and iterate these. If it fails this way, do I get back what I expect? A lot of the wrappers, you think about it, what you're doing is you're going to grab the exception, you're going to massage it somehow, and give back a new message. So you might have, if it fails this way, this is the message I should get back. Or I might create an exception object. Or I might do something else. I can say, if it fails this way, do I detect whatever else is supposed to happen? And I can force it to do it in this way. And this is nice because now I can put these into an array of something. And instead of having 5,000 little OKs written around, I can just have a big array of what I wanted, what I expected, feed it through, get it out. And I can set the count equal to the number of these things, and I'm done. People use local here much? Okay, yeah, a lot of people thought that local went away with my, and it really doesn't. There are still things that it's quite useful for, aside from global values, because you can localize the value in a hash, or you can localize the value in a glob. Here, I'm localizing the subroutine. Basically, what I'm doing, if in the case of a class, I'm creating a temporary method. It's a one-shot method that, when I exit this scope, is going to be reset to what it was originally. Now I can go in here, I can run a test. As soon as I exit this scope, the method is reset to what it was originally. And this takes some getting used to, because most languages don't let you arbitrarily override things for a limited amount of time. But this can be a big help in testing, because I can say, does it fail here, does it fail there, does it fail there? I can take one object and just beat it up in every place that it lives. I can also override core global. Anyone done this? This is where you really get to blow your kneecaps off if you don't do it right. Let's just say I want to see if something calls exit. We've got a sanity check that's supposed to blow up. What I'll do here is I can override core global exit. I am taking Perl and shoving a new thing in for the exit function. And what it does is it increments, does it exit? Well, now I can say eval whatever my thing is with whatever arguments. When I'm done, I can ask, did it try to exit? It won't have succeeded. I may have left any number of things in a bad state, but I know that it exited. As you pointed out, this is really good for small, specific tests. You know, don't go hacking core Perl for the fun of it, but this can be really useful. Think about it. Let's just say you want to test, did something exit when I called a specific function? How else would you do this? You know, OK, I didn't, you know, if it exits, I'm never going to get a return from OK. So this allows you to keep going even when you can override die. You know, what did it die with? And get back the error message from die. This works pretty well if you've got something that's going to detect a thing or die, override die, see if it went with the correct message, and then exit. I mean, this is a very small test. What will happen with these mock objects, mock Perl, whatever, is you'll use devel coverage, and someone will say, but you never reached this obscure branch here. And you'll have to think, what would cause that? Oh, the operating system crashed halfway through you will fake the operating system crashing, and you will finally turn that line green, and you will go through creating tests. You know, most of the time, most of the tests run the standard part of the code, and you've got all these little obscure edge case branches that keep your head from getting lopped off. And you'll use these mock objects to create those weird edge cases that exercise the part of the code that detects, /dev being unreadable or something. And you can go through one by one, and it'll be an iterate. You'll run cover, you'll say, wait a minute, there's this piece that's missing. And you write a new test. And that installs, it fakes die, it does something so that it forces that piece to run. And you can see, did it work? And you keep going and going. The more obscure the part of the code is that you're trying to create, the weirder the mock object is, probably the smaller the test will be. You get down to tests where there's one outcome. Yes, I correctly exercised this one if block. But then you know you did it. Now, laziness is a virtue. We all know this, right? Yeah. We also don't like cut and paste. Having Perl do work is good for you. Machines work, people should think. So one thing I've done, I have to test a lot of things with some of the genetics code where I'm using a sequence, and I'm going to chop it up into 32-character chunks and 40-character chunks and 60-character chunks. And I mean, do you really want to write a separate test for every one of these? You sit there hardwiring little bits and pieces of things. So what I've got is a couple of things. One of them is a quick and dirty automated way of just validating that I haven't broken anything outright. Require OK and use OK do just that. They require something and tell you if it required. The neat thing about it is without having to play funny eval games, you can have the name of a package in a variable and use it. So this is great for standard testing. So I might have something where I've got a lib directory. If I chop off everything up to lib, replace all the slashes, say, with dashes, I can create a test that will go and load something. But now all I have is a bunch of symlinks. My test's driven by the base name of the file that's running them. So now all I can do is I can create a bazillion little symlinks that'll do use OK on a file. It'll check a couple of things about it. Before I push something into Git or Subversion, whatever, I can check if the next guy tries to run this, will at least compile. So the trick here, this is a generic testerizer. What it's going to do is check, it's got some madness. It will strip the .t off, take the base name, strip off the leading number, replace dashes with double colons. Bingo, I've got a package name. I can use OK it. Has anyone here ever typoed a package name? Yeah, I got a lot of hands on that one. Here's a neat test for you. Because everything everywhere always inherits from universal, and version is in universal. If the package you just loaded, if use OK worked, I found it on the disk, right? If it cannot version, then I botched the package name. So this people, people have seen this and said, that's stupid. Every class can version. Well, no, if you misspelled it, it can't. Because it's not there. Really simple test for a botched package name. Anything, can, is a, can, whatever, just something from universal. If it is a universal, that'll succeed because everything that's just automatic. And then I check, I insist that the people I work with, we always put version numbers into things. So you can check, can it version? And that will at least tell you that it's there for real. This is usually enough. Now you notice the done testing and the lack of a test. There's an if block here. I'm going to run either 1 test or 3. It does me no good to have a count. There's no way to put a plan into this because I don't know how many it's going to run. So this is an example of where done testing does you a better job. But you can do this. You can have something that will find all of the files under lib, strip the PM off of them, replace a few things, and if you watch this, with the chomp and the rest of it, what this is going to do is generate a directory full of 01-mumble.tet file, symlinks, and I can type prove. And in one step, I can check all my modules. What's cute about that is also I've got 0 zeros. There's a module called config::any that will read JSON, INI, XML, whatever insane formats people have used for configuration since day one, it will just read. And it will blow up if they're not readable, if they're not usable. Well, now you can see how, using the same technique, I can have something that just at least reads all of my config files. Has anyone left an angle bracket out of an XML file? Have gotten a mismatched tag once or twice? Yeah, well, if I do this, I can tell, are all of my modules likely to run? If I've botched the configuration files, nothing until those .00s are going to run. It's a waste of time testing anything else because all of them are going to fail when they get that botched XML config. So test that, add that test. And it's really, you can see it's easy enough to write. It uses the same basic format as the 0-1 tests, the tests that use OKs. Now what I do with I can do this, make a shell macro out of it. I do a git pull and I make the generic links. If someone added a new module, bang, I'm going to test it. If I do prove with jobs equal to and state equals save, that'll run them in parallel, and I'll know which ones failed. I can rerun things that puked. And if they work, I do a git tag, it passed prove. That's all I'm saying to you. But now anyone can go back and snag this thing. When is the last time it passed prove? If you need to bisect something, you can start from this tag and go forward and find out where you botched the syntax. Cold coffee. If it worked, you push it and push the tag, and now you've got a history of every time that the thing survived. You can look at it over time. You can see the progress. Also, these tags, if it passed, are if you've got a more rigorous QA, does it prove -R or something, you snag the tag instead of doing the head. So you can get the last provable one and do the full QA on it. Exercise. Does everyone know how? Exercise is good for you, man. It's good for your objects. It's good for your classes. And most of us don't do enough of it. You don't really push a lot of tests against something to see what it does. So the object exercise keeps things healthy by making it really, really easy. It's sort of like a treadmill for your object. And what it allows you to do is something like this. You have a bunch of methods and arguments, and you have what you expect them to return, which can be undef if you think they'll fail. You pass me an object. If you use the thing, it will stuff $exercise so that it doesn't override any method names into your space. And you can dispatch your object into exercise with all of these tests, and it's just going to iterate them. Call the object, $object points to $name with @args. What does it hand back? It evals it so you can check for failures. So I've got an array of tests. What this is going to do first, it's going to run name. It's going to run object to name, and it's going to expect Joe Blow back. Then it's going to run street, and it's going to nowhere, and it's going to run street with number as the argument, and it's going to expect 1. And it'll display the message check street number instead of just a generic thing about what it was calling. This makes it really easy to generate the tests because you can have a flat file with things to execute and things to get back. Turning those into a bunch of array refs is trivial. I developed this when I was testing something where it was a metadata manager for a database. And we had all these relationships. You had queries that had names, you had queries that had subcomponents, you had subcomponents that had subcomponents. And trying to write an OK for each of those, it would have been a heat death of the universe before I was done typing. Oops. So now what happens is I can run this and just get done with it. I could have an array stored in an external file as XML, as JSON, as whatever you like. It's easy to edit, and you don't have to hack all your stuff. And this actually is pretty close to a complete test suite. You can also use this for loading fixed data. If you've got a bunch, again, the classic thing we've all got is you've got a database with standard test records, put all the test records into arrays, map them onto do with some SQL or whatever, or insert on your wrapper, and you can insert a whole bunch of records without having to write 500 OK did it insert right statements. There's some good examples in the pod for that. I'm going to go through a couple of these pretty quickly. There's documentation for all of these, but just in the back of your mind, these are out here. Test builder, one of the problems you've got is your test.t files just get too bloody big. So with this, what you can do is have a bunch of modules that you add to an object. You can break your tests into usable chunks, and you get a singleton object that every time you redispatch it and create it, you get the same one, and it accumulates all the data through all your modules. Makes it a little bit easier to test things in place, because you can break your tests into reasonable chunks and then accumulate them all at the end. Test build tester wraps your tests. It ignores the outcomes and just checks whether or not they returned OK or not. So you can test whether your test correctly detected the fact that something wasn't OK. This is getting into I think, therefore I am, land. But if you've got really big test suites and you've got a really heavy-duty test framework, this will allow you to test the framework and make sure you didn't botch it before you find out that 500,000 tests were done wrong. Prove, you can save the state, which means that you can rerun only the failed tests. Perl.prove. Prove. This has saved me more time than I want. You get 18,000 tests, 6 of them fail. Fix something, save the state with the prove. Now you might find that your shop uses only one or two, one of these other languages, C, C++, Python. Use inline. Anyone here have to test API libraries that aren't written in Perl? Yeah, that's always fun. You've got the Java libraries, the C libraries, the C++ libraries, part of it's Python. Inline is your friend. This will test some C code. Pretty trivial C code, obviously. But if you had a bunch of C wrapper functions, you could test them with prove. Use inline, put the calls to your wrappers into it. Do you get back what you expect? You can regex them. It's a whole lot easier to use regexes in Perl than it is in C. So you can do a lot with the inline if you've got C and Java and you're trying to exchange data between them. You can check whether or not you can do that properly with inline. And if I do something like this, I get output. Yes, C can add. Not surprising, but if this was a bit more complicated, that could fail. You can call libraries. You can have iterative. You can check whether the library can do things. Again, inline supports these languages that I snagged out of the pod. There might be more. Adding languages is fairly easy. For the number of us that are checking Bufunge on a daily basis, fine. But especially the C++, Java, Python, Ruby, it's nice to be able to test everything in one place. You can have one consistent framework for all of it. And actually, there's one other test. Let's just say you had one of these quad rotors here. And, I actually timed this right. And you wanted to write a module for it. You'd probably have to test it, right? So if I do this right, here we find out. Yeah, I'm still connected to it. So what'll happen, I don't pick it up, sorry. But there's a module that will actually control this. And you want to test the module. You want to see whether the pieces work. So you've got a basic set of actions. I want it to take off. I want it to wave around. I flip left. I want it to land. And when it's done, I want to execute a send, and send an expected value to see that I've flushed the channel completely. So I'm going to plan 2 tests more than the number of actions, because I'm going to validate a couple of things. Here's where bailout is good. I'm going to create the driver. I'm going to create the connection object. And I'm going to bail out if I fail to connect. It's not going to do me much good to try and test this thing if I can't talk to it. There's got to be a failure. If this thing is floating over your head, you probably don't want to have to snag it out of the air, right? Write something that does a cleanup. The last action is land. So this is what I'm going to do is I'm going to iterate these. It'll pass every time one of these does what it's supposed to. I'm going to put a note in that shows us what to expect that it's doing. And then I'll iterate these. I'm going to check the end of channel depending on what I push through it. So if I run the test, and you can't see it running, so I put it in here, you get something like this. And the last thing it got was the receive coming back from the array. So this was actually done with prove. So if you test anything, it's no joke. This could be a robotic arm picking stuff up and putting it down. You could connect this to an Arduino or a Raspberry Pi running a robot, and you can do a prove on a robot. So it really is test anything. So the short summary is, this cpantesters.org is a good place to check. The Perl culture of testing is a useful thing. Just take part in it. Notice that it's there. And that is wrapping around. So we're done. Oh. Thank you. I'll shut down and get out of Tim Bunce's way.